Hi everyone. So in this video we will study about power calculations on transmission line, or you can say power transfer on transmission line, because just as you connect some generator across a transmission line and just as you close the switch there will be some waves generated and those waves will carry some power. So we will study that, but first let's see a simple concept of network analysis. So this is a ZL impedance. A ZL impedance is there. Across this ZL impedance we are having VL voltage, and because of this VL voltage some IL current is flowing in this ZL impedance. Now this ZL impedance is R plus JX. So what will be the power dissipated in ZL? A lot of ECE students will find this question difficult because they do not study complex power in that much depth. So I will simply tell you how to find the power dissipated in ZL. So whenever we find the power, we will always solve with respect to the current. Are you getting this point? If the load is complex, the voltage is sinusoid, IL is also sinusoid or cosinusoid, then always we will solve the problem related to power dissipation by how? By the current. Okay. So what is the formula I am going to apply? Half mod of IL square into real part of Z. Real part of Z means real part of ZL. Real part of ZL means resistor only, because power will be dissipated in resistor. Inductor and capacitor are storing element. Here this X could be negative or positive, it could be capacitor or inductor. They are storing element. If you talk about dissipation, power dissipation, that means you are talking about resistor only. So what you are going to do? Half mod of IL square, and real part means I am talking about resistor. Okay, this can be written as RL plus GXL. So here I am writing RL. And what is your mode of IL? Your mode of IL is mode of VL divided by mode of ZL. And if I am saying mode of IL, that means I am talking about maximum current, not RMS current. Here all these formulas are maximum, not RMS. Nothing is RMS. Okay. So this would be your IL. We will solve a problem, it will be more clear to you. So what we need to do, if I need to find the power dissipated in the load, then half of mode of IL into resistor. And why I am putting half? Because this is the maximum, this is not RMS. IL is the maximum current. Mode of IL means maximum current I am talking about. So let's solve a problem. So this is what is given, that this is a ZL impedance 50 plus J 100 ohm. This is the impedance. Mode of VL is given as 12 volt. You need to find the power dissipated in the load. So what formula I am going to apply? I have told you one simple thing, that the power dissipated, if I need to find, then always I will apply this formula. I will always solve with respect to the current into the real part of ZL, which is RL, right? This I am calling as RL plus JXL. So here RL is 50, but I need to find mode of IL. So what will be my mode of IL? Mode of IL will be mode of VL divided by mode of ZL. Here if I am finding IL, so I will not divide by RL, I will divide by mode of ZL. What is mode of ZL? Under root 50 square plus under root 100 square. So what is my VL? My VL is 12 volt divided by what is ZL? Mode of VL means maximum voltage. Maximum voltage is 12 volt. And what is my ZL? ZL is 50 square plus 100 square. So this is your mode of IL. Okay. So what you are going to get here? 1 by 2 into mode of IL square. So 12 into 12 divided by this square. What this square would be? 50 square plus 100 square into RL. If you solve step by step, your answer will be correct. Now you just need to do this calculation. So this will be the power dissipation. Are you able to understand the point? So this will be used in our analysis somewhere. In some of the question it will be used, and I know a lot of EC guys are not comfortable with that. So how we need to solve? If ZL is given, VL is there, IL is there. So first thing I will apply the formula mode of IL square into real part of ZL divided by 2. Why by 2? Because this is the maximum current I am taking. So that's why 1 by 2. Now real part of ZL is resistance only. Now I need to find mode of IL. Mode of IL can be found by mode of VL, which would be given maximum voltage across this load divided by the total impedance. What is the total impedance? Total impedance is under root RL square plus XL square. So that will be the total impedance. And then I will simply apply the formula and we'll get the answer. So I will just solve it using the calculator and then I will write down the answer. So answer is coming out to be 0.288 watt. Okay. So this is the power dissipated in the load. So that's the answer. So this is how we need to solve. Now let's come to our concept, that how we will do the power calculations on a transmission line. So just as the switch is closed, just as the transmission line switch is closed, then what happens? From the source here V0 plus is generated, right? V naught plus is generated. Now in electric field, if E naught was generated, E naught sin omega t, this kind of sin omega t minus beta z, or E naught cos omega t minus beta z, this kind of function we were having, right? This kind of traveling wave we were having. Here, what kind of traveling wave we are having? V naught plus e to the power gamma y, or V naught plus e to the power, then V naught minus also comes after reflection. So these kind of wave we are having. So in EM wave, what was the power associated with this one? That was E naught square divided by 2 eta naught. So what do you think, what will be the power associated with this one? That would have been, since V naught plus is generated, so that power would be V naught plus square divided by 2 Z naught, right? V naught plus square divided by 2 Z naught, because neta is intrinsic impedance and Z naught is characteristic impedance, not neta naught. There we used to write only neta. So I told you, analogy also I told you that intrinsic impedance and characteristic impedance both have the analogy, because neta was your under root mu by epsilon, and Z naught was your under root L by C. So analogy also I told you. So with respect to the power incident, just as the switch is closed, V naught plus will be generated, and V naught plus is generated, then the power associated would be V naught square divided by 2 Z naught. This is the power just as the switch is closed and at the source end. I am calling this as x equals to 0 and this as x equals to L. What is the name of this power? The name of this power is power, time average power incident on the line. I hope you remember what do you mean by time average power. That means pointing power. In pointing theorem we studied about it, time average power. So time average power incident on the line. This is that time average power incident on the line. Okay, name is very important. This word is very important. Incident. Why I am calling it incident? Because just as the switch is closed, then this much power came into action. What is that? This is equals to V naught plus divided by 2 Z naught. Now what will happen? Now this power will travel across the transmission line. So in EM wave, this was the initial power generated. When it was traveling, then how it was getting reduced? If the medium is lossy, then it was getting reduced by this minus 2 alpha z cos theta neta. I hope you remember it. If you revise your pointing theorem chapter, there we talked about it. E naught square by 2 neta, it is at z equals to 0. But when it travels down, it will lose its amplitude, e to the power minus 2 alpha z, and cos theta neta will also come into action. So similarly, here the power generated was V naught square, V naught plus square divided by 2 Z naught. But now if it travels along x, here we are not calling y equals to 0 and y equals to L. No, we are analyzing with respect to x now. So along x we are going. So that means we are covering Z, we are covering the L distance. So when we cover the L distance, when we reach at the load end, then how much power will be there? If the medium is lossy. If the medium is lossy, then how much power will be at the load end? So what will be the value of PA? What do you think? What will be the value of PA? So PA will be V naught square, V naught plus square divided by 2 Z naught. This much power was generated. Now it started traveling minus 2 alpha x. Why I am putting x? Because this I am assuming x equals to 0 and x equals to L. But if I am talking about PA, PA is the power at load. Power at load. So for that I need to put a L, because load is at L distance. And then cos theta Z naught. Similarly, neta can also have some angle, right? Because neta is a complex quantity. Similarly, Z naught can also be complex. But in our problem, 100% Z naught will be real only, right? We have seen Z naught equals to 50 ohm, 75 ohm. So this theta Z naught will become 1. Also in our problem, lossless transmission line are given, right? In our questions we have seen that in 99% of the questions, lossless transmission line is given. If lossless, that means alpha is 0. So this term will also be gone. So that means whatever the power that is generated, the complete power will reach towards the load. That means there is no loss in the transmission line. So whatever that is generated here, the complete will be coming towards the load. Now this is not this power is not getting into the load. Okay, this is just the power near the load. Now it will strike to the load and some power will be reflected and some power will be transmitted. So this PA is not the power that is transmitted to the load. No, this is the power which has reached to the load. Are you getting this point? So till now what all things have happened? We close the switch, V naught plus voltage was generated. With respect to this V naught plus voltage, this was the power. V naught plus whole square, V naught plus square divided by 2 Z naught. Now if it is traveling and the medium is lossy, then this is how it will lose its amplitude. But if the medium is lossless, so what I am telling is that if the medium is lossless, then it will not lose its power. Pa, if the medium is lossless, that means whatever the power that was generated, which power was generated? V naught plus square divided by 2 Z naught. So this power was generated, and even if it covers the complete distance, it will not lose its amplitude. Also, theta Z naught will also be 0. Why theta Z naught is 0? Because if Z naught, if medium is lossless, that means Z naught is real. Let's just say 50 ohm. Then what will be the value of theta? 0 degree, because 0 is 1 only. So it will never lose its amplitude. So whatever that was generated, the complete has been traveled till the load. Now in the load, some part of the power will be reflected back and some part will be transmitted. Some part of this PA will be reflected back, some part of this PA will be reflected back, and some part will be transmitted. So that I need to write down now. So time average power delivered to the load. Delivered to the load means it has been transmitted. In EM wave, what we were studying, that some power is coming, we used to call it P in. Okay, then I would use to say some power will be reflected back and some power will be transmitted in the other medium. So how we used to write it down? How much power will be reflected back? Gamma square P in. And how much power will be transmitted? 1 minus gamma square P in. If you remember the case of 1 minus gamma square into P in. If you remember the case of normal incidence, there I told you P in power will be coming, gamma square P in will be reflected back, and 1 minus gamma square P in will be transmitted. Same thing will be happening here. Here what I am saying, that how much power is reaching? PA power is reaching. How much power is reaching? PA power is reaching. So how much power will be delivered? So, or first I am writing how much power will be reflected back. So reflected back power will be gamma square PA. Gamma is the voltage reflection coefficient or current reflection coefficient, anything you can take, because you are taking the magnitude and the square. So gamma L square, actually gamma L square I need to write. What is gamma L? This is gamma L, the voltage reflection coefficient at load. So gamma L square into PA, whatever the power that has reached, gamma square times of that will be reflected back, and 1 minus gamma square will be transmitted. Basically total power came was PA and gamma square was reflected back. So how much is transmitted? This much is reflected back. So this much is subtracted. So this much power is transmitted. And what is this? 1 minus gamma L square into PA only. So till now what we have studied. Look, this is a very confusing topic for a lot of students. But if you just listen to my words, whatever that I am saying, just solve the problem in that manner, you will never find it difficult. Otherwise, like a lot of teachers don't even teach this particular concept. Okay, I have seen a lot of teachers skipping this part of power transfer in transmission line, and otherwise there will be a lot of confusion. So, but we will understand the meaning of every term. What all we have studied till now. Just as the switch is getting closed, V naught plus is generated. V naught plus whole square divided by 2 Z naught. That much power is incident on the transmission line. This much power is incident on the transmission line. Now this is traveling through the transmission line. So if it is traveling and if it is a lossy medium, mostly in your question 100% I am sure that they will give lossless medium. But even if it is lossy, then how it will be reducing its amplitude? E to the power minus 2 alpha x. X is the distance that has been covered from the source end. But here we are talking about the load end, so I have put x equals to L. Along with that into cos theta Z naught. Okay. If it is lossless, that means theta Z naught will be 0 and alpha will also be 0. So there will be no loss in the amplitude. So here V naught plus was there, V naught plus only will be reaching here. Okay. So the power will be V naught plus whole square divided by 2 Z naught. So this we have studied. Now some power will be transmitted to the load and some power will be reflected back. So how much power will be reflected back? The power that will be reflected back will be gamma square PA, gamma L square PA, and the power that is transmitted to the load, that will be 1 minus gamma square into PA. This is what we have studied. And for lossless transmission line, PA here only I have written, which is equals to V naught plus whole square divided by 2 Z naught. Okay, which is equals to P in plus only. Basically for lossless transmission line, whatever the power that was generated here, the same power will be reaching towards the load. I am not saying the same power will be reaching into the load. No, same power will be reaching towards the load. Now how much power will be going into the load and how much power will be reflected back, that will be decided by the gamma. So power reflected back will be gamma square PA, and power that is going into the load, or you can say power that is delivered to the load, will be 1 minus gamma L square into PA. Is that clear to you? All good? Now, one thing I focused on this part, incident. Time average power incident on the transmission line. Now there is another term. Okay, listen to me very carefully. What was this term? Time average power incident on the transmission line. Now there will be another term. What will be that term? Time average power delivered to the transmission line. Okay, time average power delivered to the transmission line. So both are two different things. This is incident. Incident means just as you close the switch, then because of V0 plus, how much power is incident. And if I am talking about delivered, that means I am taking incident, reflection, then again incident, again reflection, and again reflection, a lot of reflection and incidents, all I am taking place. And what is the total power that is delivered to the transmission line? Are you getting this point? There are two terms. One is the power incident on the transmission line. That means I am only talking about V0 plus. That's it. There is nothing else. Just as you close the switch, then power will be incident on the transmission line. But if I am talking what is the total power delivered to the transmission line, if I am talking about power delivered to the transmission line, that means I am talking about all reflections and incident in action. Like V0 plus would be coming gamma L V0 plus, gamma L gamma G V0 plus, everything I am taking into action. That means it is the steady state power which has been delivered to the transmission line. So at steady state, what do? We replace our circuit with at steady state, what do? We replace our complete transmission line with Z-in. So there are two different terms. Power delivered to the transmission line is not P in plus. It is not your V0 plus square divided by 2Z0. No. Here what all things will come into action? Here V0 minus will also come into action. So power delivered and power incident, two different things are there with respect to the transmission line. So if they are asking power incident on the transmission line, then this is the formula. And if they are asking power delivered to the transmission line, then which formula you will apply? So when we do the calculations, okay, when we do some complex calculation, we get to know that the power delivered to the transmission line is equals to the power delivered to the load. What do I mean by that? At steady state, how much total power is delivered to the transmission line is equals to this guy. Okay, this is what we get when we do the calculations. We will prove it using one of the question as well. In one of the questions, we will prove this thing, that how we will find the power. First, we will find the power that is delivered to the load, and then we will find the power that is delivered to the transmission line. We will find the power that is delivered to the transmission line, and then we will equate both of them. We will get to know that both are the same thing. What I am saying, at steady state, time average power delivered to the transmission line is equals to the time average power that is delivered to the load. And what is this? This is your 1 minus gamma square into PA. Say yes or no. This is equals to 1 minus gamma square into PA. And for lossless, it would be equals to 1 minus gamma square into V0 plus square divided by 2Z0. So this thing is very confusing for the students. Like sometimes in the question it will be asked that what is the time average power incident on the line, and sometimes in the question this will be asked that what is the time average power delivered to the transmission line. So students think both are the same thing. No, delivered to the transmission line, that means complete delivery they are talking about. Incident, reflection, everything is coming into action. So that means they are talking about steady state. But if they are talking about incident, that means only V0 plus they are talking about. Now what do you think, what could be the other way of finding power delivered to the transmission line? Power delivered to the load, or you can say power delivered to the transmission line. Both are the same thing. What did I say? Power delivered to the transmission line or power delivered to the load. Both are same. We will prove it as well using one of the questions. Okay. So do not worry about it. But what is the other way we can find it out? So what do you mean by power delivered to the transmission line? That means at steady state, I am doing my analysis. So at steady state, what I can do? I can replace this complete transmission line with its input impedance. So this I am calling as my input impedance Z-in. If I am talking about the power delivered to the transmission line, if I am talking about power delivered to the transmission line at steady state, or if it is written that what is the time average power delivered to the transmission line, that means they are talking about steady state only. So now what I need to do, I need to replace this transmission line with Z-in. So first I will replace my transmission line with Z-in. I know like it may feel like there are a lot of things, but no, there are not lot of things. There are only few terms. Till now we have studied power incident, then how much power is going towards the load, how much power is reflected back, how much power is incident, and then we have studied that power delivered to the transmission line is equals to the power delivered to the load. Now we are just finding the other method. What is the other method? That I am replacing my transmission line. Here it is having some VG, it is having some ZG, and I am replacing my transmission line with Zdin. So this will be your Zdin. Okay. So this is your VG, this is your ZG, this is your Zdin. So now the power dissipated in Zdin, whatever the power that is dissipated in Zdin, what I am talking about, power dissipated in Zdin, that means this thing I am talking about. So whatever the power that is dissipated in Zdin, that will be equals to the power delivered to the line. So what I am saying, power, time average power delivered to the line, time average power delivered to the transmission line will be equals to power dissipated in Zdin. Are you getting this point? Okay. So you just need to find the power dissipated in Zdin. And how will you find that? First you will find this current Ig. Then what that would be equals to? This would be equals to 1 by 2. Forget about this. This would be equals to 1 by 2 mod of Ig into real part of Zdin. Into real part of Zdin. So better I should write it downward only. So this will be equals to 1 by 2 mod of Ig square into real part of Zdin. Are you getting this point or not? So let's summarize what all we have seen till now. Just as the switch is closed, V naught plus is generated. So that is the power that is incident on the transmission line, V naught plus square divided by 2 Z naught. Now this power will be traveling through transmission line. If the transmission line is lossy, then this is how it will be losing its amplitude. If it is not lossy, then complete power that is incident that will be reaching towards the load. Now some power will be reflected back and some power will be transmitted to the load. Power that is reflected back, that will be gamma square into PA. Power that is transmitted to the load, that is 1 minus gamma square into PA. Okay. Now we go to know another term. What is that term? That what is the power delivered to the transmission line? If the word delivered is written, that means they are talking about all incident and reflection, everything into action. That means that power delivered to the transmission line, we get to know that it is equals to the power delivered to the load. So whatever the power that has been delivered to the load, that is equals to the power delivered to the transmission line. This we get to know when we do the calculation. Now what is the other method of finding power delivered to the transmission line? The other method is you replace the transmission line with this Zdin and you find power dissipated in this Zdin. And if I talk about power dissipation, that means I am talking about only resistor. So what I am gonna do, half mod of Ig square and real part of Zdin, that means real part of this guy. That would be its resistance only. It can have some resistance as well and some capacitance or inductance as well. So based on that, we will find out this power dissipation. Certainly we will solve the problem. When we solve the problems, it will be more clear to you. So 3 problems I will pick up. There we will solve all kind of cases. Okay. So do not worry about it. This is a very confusing topic, I know, but now it will be all clear if you just listen to my words and solve in the manner that I am telling. Now there will be another term. There will be something else will also be asked. What is that? The time average power delivered by the generator. Okay. That this generator, how much power this guy is delivering. So this guy is delivering PG power delivered by the generator. So what that would be equals to? That would be equals to the power dissipated in ZG. That would be equals to power dissipated in ZG plus power delivered to the line. Delivered to the line. Right? So what do you think? What will be power dissipated in ZG? That would be half Ig square into ZG, not ZG, half Ig square into real part of Zg. That means its resistance value plus what is the power delivered to the line? When we replace it with Zin, when we replace this with Zin, and then we need to find the power dissipated in the Zin, that would be equal to the power delivered to the transmission line. So what that would be? Plus half mod of Ig square into real part of Zin. Or you can write it down, half mod of Ig square into real part of Zg plus Zin. Are you going to mug up this formula? Absolutely no. Nothing we are going to mug up. Okay, this is a very easy topic which seems like a complex topic, but nothing we are going to mug it up. We are not going to mug up this formula. This is a very simple thing. No, from source, from this generator, I need to find the power delivered. That means some power this Zg will eat up and some power this transmission line will eat up. So how much power this transmission line will eat up? That means how much power will be delivered to the transmission line? That will be equal to the power delivered to the load, or that will be equal to that you replace it with Zin and you find out its value. And how do you find out that value? Half mod of Ig square into real part of Zin. This we have already seen. Okay, and some power will be eaten up by Zg. How much power will be eaten up by Zg? Half mod of Ig square into Zg. So I hope you are getting to know what we are doing. Now we will solve the problem and it will be more clear to you. So let's write down the summary first. Okay, simple summary we are going to write down. So what is the time average power delivered to the load, or it can be called as time average power delivered to the transmission line. So what that was equals to? Time average power delivered to the transmission line. So that was equals to, directly I can write 1 minus gamma L square into PA. Okay, where PA was, if it is a lossy transmission line, then your PA was V naught square mod of V naught square divided by 2 Z naught e to the power minus 2 alpha x cos theta Z naught, right? But if I talk about lossless line, so what I will think, okay, line is lossless, just I close the switch, then V naught plus is generated. Now with respect to this V naught plus, I have this much power. Now since it is lossless, then complete power will be reaching towards the load. Some part will be reflected back, some part will be transmitted. So how much part is transmitted? That is 1 minus mod of gamma square, and that is equals to the power delivered to the line. Power delivered to the line. Okay. If I talk about time average power incident on the line, so that is equals to, if I talk about incident, so only incident means just as the switch is closed, then this much power is incident. Okay. And what is the time average power delivered by the source, or you can say delivered by the generator? Along with that, it has some method too as well. So here I am writing plus another method. Which method? That replacing your line with Zin. Replacing your line with Zin. I will prove it that both of them, this thing and this thing will give the same answer. I will prove it. Okay, in one of the question I will prove it that this and this are giving us the same answer. That power delivered to the load, this formula we got from power delivered to the load, and this formula we are getting from power delivered to the transmission line. Both will be equal. We will see it. Okay, both will be equal. Always both will be equal. Yeah, so here I am writing plus another method. And what is the time average power delivered by the generator? So that will simply be equals to, this will simply be equals to power delivered to the line plus power dissipated in Zg. Okay, well and good. Now let's start our questions. So these kind of questions will be given. So what do you think? What kind of question is that? So here better I should make a switch, right? Have you seen this problem anywhere? Or they are talking about time average power delivered to the line, load and power delivered. So no need to make a switch. Simply a line would also be there, because they are not talking about P in plus. What they are talking about? Time average power delivered to the line or time average power delivered to the load. And in the third one, they are asking time average power delivered by the generator. So in the first question, what they are asking? Time average power delivered to the line. They are not talking about P in plus. What they are talking about? Time average power delivered to the line. What that is equals to? Time average power delivered to the load. So A and B will have the same answer, right? So by both of the method we will solve. So first we will solve by method 1 for A and B. For both A and B, what is the method 1? That time average power delivered to the load. Time average power delivered to the load is equals to time average power delivered to the line. And that is equals to, just as you close the switch, then how much power is generated? Just as I close the switch, V naught plus is there, and that will have V naught plus square divided by 2 Z naught power. And how much power will be delivered to the load? Gamma square will be reflected back, and 1 minus gamma square will be delivered. Right? This formula we have already seen. 1 minus gamma square will be delivered, and gamma L square will be reflected back. Is that clear to you? Okay, so this is the time average power delivered to the load and time average power delivered to the line. Now, how will you find V naught plus? Do you have the value of Z naught? Yes, I have the value of Z naught. Gamma value I can find? Yes, gamma value I can find. And how can I find value of V naught plus? So in the last lecture only we studied how to find V naught plus. So when V naught plus is generated, that means it will see Z naught impedance only, because at that time there is no reflection. So only it sees Z naught impedance. So you will replace your transmission line with Z naught. So if I replace my transmission line with Z naught, so what is the scene? That this is my 300 volt. Here my Zg is there, which is 50 ohm, and my Z naught is also 50 ohm. So I will completely replace my transmission line with 50 ohms. So this is also 50 ohm. This is also 50 ohm. So here I get my V naught plus. So what is my V naught plus? My V naught plus will be simply divided. So 300 by 2, that is 150 volt. Right? This is my V naught plus. Z naught plus value I already know. What is my gamma L? Gamma L is ZL minus Z naught upon ZL plus Z naught. 75 minus 50 upon 75 plus 50. That would be 1 by 5. Right? So what I am getting? 150 whole square divided by 2 Z naught. Z naught is 50 only, into 1 minus 1 by 5, that is 1 by 25. So if you solve it, what you are getting? 150 into 150 minus into 24 by 25, because 1 minus 1 by 25 is 24 by 25, into 24 divided by 25 divided by 100. So you are getting 216 watt. So this is the method 1, right? 216 watt. So what is the method 1? First you see what will be the power incident on the transmission line, what will be the power reaching towards the load. Some power will be transmitted, some power will be reflected back. So power that is transmitted, that is equals to the power delivered to the load or power delivered to the line. So this is the method 1. In method 2, what do? We replace our transmission line with Z in, and we find the power dissipated in Z in. So we replace our transmission line with Z in. Now I need to find the power dissipated in Z in. So have we seen this calculation somewhere? Yes, in the last video only we saw the calculation, no? Just rewind your 3 hours. 3 hours back you were doing this calculation. Or yesterday you were doing this calculation. I don't know whether in one day how much videos you are watching, I am not sure. But certainly you were doing this calculation, right? You have done this calculation. Same, everything was ditto same. Okay, you can see this calculation. So there we found the value of Z in. Also we found the value of Ig as well. There we found the value of Ig. How we will find Ig? In that video we were calling Ig as I in. Ig as I in we were calling in that video. So how we were finding that value? So that would be equals to 300 divided by 50 plus this impedance, that is Z in. So 41.25 minus J 16.35. So here I am not interested in the magnitude. Sorry, I am not interested in the angle. I am only interested in magnitude. Because what I need to find? I need to find power dissipation in Z in. And what that would be equals to? Half mod of Ig square into real part of Z in. So half into mod of Ig square, whatever I get, real part of Z in is 41.25. So here I am only interested in magnitude. So using the calculator, what I am going to do? 50 plus 41.25. What do I know? 50 plus 41.25. What is that? 91.25. So 91.25 whole square plus, then I will put bracket 16.35 whole square, 16.35 whole square, and then I will take the under root. So 92.7 I am getting, which is the magnitude of the denominator. Then I will take the reciprocal into 300. Take the reciprocal into 300. So that will be 3.23. That will be the magnitude of Ig. 3.23. So this is the way of faster calculation that I am telling. In the examination, you need to use this scientific calculator very drastically, not drastically, very efficiently, right? So if you have downloaded this your calculator in your mobile, like it's been 4 years, not 4 years, it's been 5 years since I am doing all my calculation in this scientific calculator. Okay, I do all the calculation in this scientific calculator. I do not even use that normal calculator. So just if you do calculation in this calculator, then you will build the habit that how to solve complex problems. Okay, so 3.23 ampere, this is what we are getting. So here 3.23 whole square into real part of Zn is 41.25. So I told you that I will prove it, and once you do this calculation, you will get to know that you are getting 216 watt only. So let's confirm. Do the whole square into 41.25 divided by 2. So you are getting 216 watt only. So this is your power dissipated in Zn, or you can say power delivered to the transmission line. Are you getting this point? If they had asked what is the power incident on the transmission line, then what would be the answer? This would be the answer. What I am saying, power incident on the transmission line. This they did not ask, but if they had asked, so power incident on the transmission line is this much only. 2 into 50. That would be 225 watt. Okay. So this is the power incident, and this is the power delivered. Is that clear to you? Now what they are asking? Time average power delivered by the generator. Time average power delivered by the generator. So what I need to find? Time average power delivered by the generator. That means power dissipated in Zg and power dissipated in Zn. Right? So power delivered by the generator, that is equals to power dissipated in Zg. What that would be? Half of mod of Ig into real part of Zg plus half of mod of Ig square into real part of Zn. So complete real part only there. So half into mod of Ig square. What is Ig? Ig mod of Ig square is 3.23 whole square. Real part of Zg is 50 and real part of Zn is 41.25. What you are getting? 91.25 into 3.23 into 3.23 divided by 2. 476. Roughly around 476. Here 478.4 you are getting. So if you do the exact calculation, then this answer you will get. Here some point difference is there. So this is the power delivered by the voltage source, or by the source, or you can say by the generator. So from here this much power was going, then some power was dissipated in Zg and rest of the power was delivered to the transmission line. So there is a lot of power that is dissipated in Zg. Like transmission line is only getting 216 watt, right? From 478.4, this transmission line is getting only 216 watt. So rest of the power is dissipated in Zg only. So that is too much. But yeah, this they did not ask. So I hope you got the point what they were asking, right? They were asking that time average power delivered to the line, that we found out, but that will be equals to time average power delivered to the load. So what do you think, which method is easy, this one or this one? This is easy, right? Because here we do not use to find any Zn or anything like that. Simply I need to find V naught plus, then I do V naught plus whole square divided by 2 Z naught into 1 minus gamma L square. I simply get my answer. That's it. But here you need to find Zn, then you need to find Ig, then you need to find the power dissipated in Zn. A big task, right? But I will show you some questions where you cannot even apply this formula, because I will not give the Z naught value. If I don't give the Z naught value, then can you apply this formula? No, but you can't even apply this formula as well if I don't give the Z naught value. But let's just say I say that this is my lambda by 2 line, okay, and my load is some ZL 75 ohm. I'm not giving you Z naught value. I'm not giving you Z naught value. Then can you find Z in? Yes, you can find Z in, because for lambda by 2 line, this ZL will be transferred here. So Z in will be 75 ohm. If you can find Z in, then you can do all these calculations. But if you are not having Z naught value, then there is no chance that you can do this calculation. So there you will need to apply this formula. So basically, I will set up my transmission line as lambda by 2 length only. So there for Z in calculation, I do not need the Z naught value. So in a manner, I will set it up that I don't need my Zn value. I do not need my Z naught value for my calculations. So I will, if I don't give Z naught value, then you will apply this method only. So that's why both of the methods are important. Okay. So this was the power delivered. Now let's solve the next one. So the circuit shown in the figure consists of a 100 ohm lossless transmission line terminated by the load ZL 50 plus J 100 ohm. If the peak voltage, if the peak value of load voltage is measured to be 12 volt. So this is the peak voltage here, that is 12 volt. Then what you need to find? Time average power dissipated in the load, time average power incident on the line, and time average power reflected by the load. And this is a lossless transmission line. So try doing it on your own. You can do it. If you have good enough brain, you can do it. Certainly you can do it. What you need to do? First, they are asking time average power dissipated to the load. Time average power dissipated to the load. What that would be? Half mode of IL square. What is my IL? IL is the current flowing into the load. Right? So half mode of IL square into real part of ZL. So what is mode of IL? Mode of IL is mode of VL divided by mode of ZL. What is mode of VL? Mode of VL is 12 divided by mode of ZL. That would be 50 square plus 100 square. Right? So from here, this value I can put. What is real of ZL? Real of ZL is 50 ohm. What is real of ZL? Real of ZL is 50 ohm. So have we done this calculation? Absolutely, we have done this calculation. Where? Here. So this is how I make my script. Okay. Always I will solve the tougher part even before the starting of the problem, so that you get comfortable. Otherwise, if I had taught this part in the problem only, then you wouldn't be understanding anything. So this is some another problem. That problem is something else. If I combine both of them, then that makes a good problem. So this is the way things are being taught. That first you break down the problems and then you combine them. So first I have broke it down. Then what was the power delivered in power dissipated in the load? That is 0.288 watt. This is 0.288 watt. So this is the power dissipated to the load. Can you tell me what this will be equals to? This 0.288 watt, what this will be equals to? What is this? Is this power delivered to the load? Yes, this is the power delivered to the load only, no? Because this much power is dissipated in the load. So that is equals to power delivered to the load. And what is power delivered to the load? Power delivered to the load is 1 minus gamma square into PA. What will be PA equals to? This is a lossless transmission line. What is your PA? PA is the power that is reaching here. PA is the power that is reaching here. Now some power will be reflected back and some power will be transmitted. We have found this transmitted power. This is that transmitted power we have found. Now we need to find the reflected back power. What they are saying? Time average power reflected by the load. What else we need to find? Time average power incident on the line. So time average power that is reaching towards the load will be equals to the time average power incident on the line. The time average power incident on the line or the time average power that is reaching towards the load, both will be same. Why is that so? Because this is a lossless transmission line. For lossless transmission line, or lossless transmission line, PA is equals to P in plus. And what they are asking? They are asking power incident. Mark this line. What they are asking? Incident, not delivered. If they were asking power delivered to the transmission line, then what would be the answer? This would be the answer. Because power delivered to the transmission line and power delivered to the load, both are same. So this would have been the answer. But now they are asking power incident on the transmission line. So power incident on the transmission line, that we need to find. We are not having the value of Rg, right? No, we are not having the value of Rg. Otherwise, I could have found V naught plus as well. But this thing I'm not going to do. Why is that so? Because I know that this will be my P in plus. So gamma value I can find. Mode of gamma L. This I can find. How I can find? ZL minus Z naught upon ZL plus Z naught. So 50 plus J100 minus 100. 50 plus J100 minus 100 divided by 50 plus J100 plus 100. So let's do this calculation. So 50 square plus 100 square. 50 square plus 100 square. And then take the under root. 111.80. I could have taken, this is the worst way of solving it actually. What I should have done is that minus 50 plus J100 divided by 150 plus J100. Now I should take common, no? Why I am doing this large calculation? Minus 1 plus 2J. I am taking 50 common. And here I will be left with 3 plus 2J. Now I can find the magnitude very easily. What will be this value? Under root 5 divided by 4 under root 13. Now gamma L square I need to do, that is 5 by 13 only. So without even using the calculator, I could have solved it. Right? 1 minus, this is your, actually, mode of gamma L is your under root 5 by 13. Mode of gamma L is your under root 5 by 13. Here 1 minus 5 by 13 into P in plus. What is the P in plus? That is 13 minus 5 is 8. So 0.288 into 13 by 8. 0.468. This is what we are getting. Yeah. 0.468. What is this? This is your power incident on the transmission line. So how much power reflected back? Power reflected by the load. So two ways are there, that this much power reached to the load 0.468, this much power reached, and how much power is delivered to the load, that is 0.288. 0.288. So whatever the answer we are getting, that is the power reflected by the load, and that's 0.288. So what we are getting, 0.18 watt. So 0.18 watt is the power reflected by the load. Or how you could have find it? Gamma square into PA, or P in you can say. What is gamma square? That is 5 by 13 into what is P in plus, that is 0.468. What you will be getting? 5 by 13. Let's just verify, into 0.468. So 0.18 only. There were two ways. Okay. So this was the answer, that is power reflected by the load. Okay. And other answer was this one. This one. This is the power, average power dissipated to the load. I hope you are understanding the meaning of each and every single term, and I hope you are enjoying this particular discussion. Okay, because this is a very confusing topic. Generally for the aspirant, this is very confusing, but we have broken down the terms in a very good manner, and now we are able to solve all the problems. So this is the last one which you can try. Probably you will get the wrong answer only, but you can try it on your own. There will be a very interesting thing that I will be discussing in this problem. This will be the last problem of our video, and we will solve it, but I will take a break because it's been 50 minutes. So I will take a break, but here Z0 value is not mentioned. And why Z0 is not mentioned? Because length is lambda by 2. Because if length is lambda by 2, you can find out Z in very easily. So which method you will have to apply? The second one. Which method? That you replace your transmission line with Z in, and then you find the power dissipated in Z in, that will be equal to the power delivered to the line. Right? So that method you will have to apply here. So think and then you tell how much power will be delivered to these load, or you can say will be delivered to the antenna. Is that clear to you? So find it out. Find it out. It is a very easy question. I will take a break. You can also take a break, and then we will resume our journey. Okay. Okay. So let's start this solution. So did you get this answer? Yes. I know a lot of you. A lot of you would have got this answer for sure, right? You must have got this answer. But now I will ask you something while solving the problem. I will ask you something that will create the confusion. Because getting this answer was very easy if the answer is written. But if the answer was not written, then there could be some confusion. So that confusion I will create while solving the problem. So here Z naught value is not given, so that formula is gone. Which formula? V naught plus whole square divided by 2 Z naught 1 minus gamma square. Because for gamma square also you need Z naught. Here also you need Z naught. Here also you need Z naught. Everywhere you need Z naught. So that formula is gone now. So which formula we are going to apply? Replacing the transmission line with Z in. So if I replace this transmission line with Z in, then what will be my Z in? Since the length is lambda by 2, so from here I will get 75 ohm. From here also I will get 75 ohm. So across CD I am getting 75 parallel with 75, that would be 37.5 ohm, right? So here across CD I will be getting 37.5 ohm. So that transmission line I am gonna make. So I should have made it in the break only, but now I will waste some time. You can skip this time wasting, okay? I will draw the line. This is how a lot of teachers teach in gate field. Like they will draw the line slowly, like this. They will waste the time there. Then they will say our content is of this much hour, this much time. Our content is too large. We teach a lot of things. But Ganta they teach the things. They don't teach anything. 75, 75, 37.5, 75 by 2. Okay. So just being a typical gate educator now. Like a lot of script work should have been done already, so that time doesn't get wasted. Student can learn as much as he can in the time he is investing. So this is what I feel. So that's why I spend a lot of time in making script first, and then I come on the screen. Like there are a lot of great educators as well who do not make script because they have good amount of experience. But there are few educators who just waste the time. Like they do not even teach the things which are required. Then they act like a god that we are the best. But here, as of now, I am wasting some time. No worries. Sometimes it's okay, right? If it is not okay for you, then you can leave, right? But you are not going to leave because you have come till this far, then you would know what kind of content has been delivered on this particular channel, right? So yeah, this is how it will be replaced. Now what I'm gonna do, I'm gonna replace this transmission line with its equivalent Z in input impedance, right? And what will be its equivalent Z in input impedance? That would be 75 by 2 ohm. So how I can replace? Simply I will copy this thing. Now this will be replaced with Z in. So what is the power dissipated in this Z in? That would be equals to power dissipated in that Z in. And that will be equals to the power delivered to the line, right? And that would be equals to the power delivered to the load. So now we are finding what is the power that is delivered to the load. To which load? To this load. And this load is 75 parallel with 75. Are you getting this point? So we are finding what is the power delivered to the load. So what is the power that is delivered to the load? 250. First we are finding the current. So let's write down the current. What will be the answer? Half the current. This current I am calling as I only. So half this current into the real part, that is 75 by 2 only. That would be half into what will be the current? Current will be 250 divided by 50 plus 37.5. This will be the current into 75 by 2. So this calculation we will do. 50 plus 37.5 reciprocal into 250 whole square into 75 by 4, 153.06. So that means 153.06 power has been delivered to this load. 153.06 watt power has been delivered to this load. Now, how much power is coming here? 153 point here to this load. What we are finding? Power delivered to the line. And power delivered to the line is equals to power delivered to the load. And what is the power delivered to the load? That is 153.06 watt. Now, there are two transmission lines, this transmission line and this transmission line. Both are ditto same transmission line. That means total power delivered to the load is 153.06. So half will be going here and half will be going here. So what did you do? 153.06 divided by 2. So that was your answer. 76.53, whatever that you are getting, here we are getting 76.68. So roughly around I will write it 76.6. This much power we are getting. So you just divided it by half, that this load, this antenna will have 76.6 and this antenna will have 76.6 and both combined is 153.06 and you told your answer. But now I will ask you a question. First thing, why did you divide the power? What was the reason why did you divide the power? That is very simple, that we have already studied in network analysis. Why did we divide the power? So this was our parallel connection of two resistances. Let's just say the antenna 1, this transmission line, this line 2 was giving us R2 resistance. This line 2 was giving us R2 resistance and this line 3 was giving us R3 resistance. And we had a power P1 here, not P1, we had a power P in here. Then how much power will be delivered here? Both are having the same voltage, right? So this resistance R would be having V square by R2 power, and this resistance R3 would be having V square by R3 power. So here you can see that voltage is same. So basically the power is inversely proportional to R2. So if a complete power from here, P in power is coming, complete power P in power is coming, then in R2 how much power will be transferred? This much power will be transferred. This is the power in R2. Are you getting this point? What did I do here? This you must have studied in network analysis. Thus from here P in power is coming. If a P in power, total power is P in. Here both of the resistance were equal. So simply R3 was equals to R2 only. So R plus R upon R plus R, that would be R upon 2R, that would be P in by 2. So in R2 also P in by 2 power was going. In R3 also there was P in by 2 power was going. But if the impedance were different, let's just say here 50 ohm was there. What I am saying, if here 50 ohm was there and here 100 ohm was there, and assuming that this power was 200 watt, this is what I am assuming, that this power was 200 watt, then what would have happened? How much power this transmission line would be getting? This transmission line would be getting 200 into inversely proportion. In the inverse proportion I will be dividing 200 into 100 divided by 150. So this would be getting 2000 divided by 15 power, and rest of the power will be given to this guy. Are you getting this point? Here luckily both were same, so we were getting the answer very easily, right? But if the resistance were not same, then you would be dividing the power in the inverse proportion of resistance. And how would you remember? That's our V square by R, V square by R. Okay, V square by R, that means voltage is same, in parallel voltage is same, so power will be inversely proportional to the resistance. And if it was in series, let's just say anyhow, if the transmission lines were in series, for series connection, what is the scene? This is your R2, this is your R3. In series connection, what is same? Current is same. So what will be the power in R2? That would be I square into R2. And what is the power in R3? That would be I square into R3. And let's just say complete power is coming, that is P in. Complete power P in is coming. So here what you can see, the power is proportional to the resistance. So if complete power P in is coming, so what will be the power in R2? That would be P in into R2 upon R2 plus R3. Right? And what will be your PR3? PR3 will be the remaining power. PR3 will be the remaining power. Are you getting this point? Fine. Okay. So this is some network analysis concept only. So now you have got to know that this both of them are having the same impedance 75 and 75 only. So both will be given half of power. Now my doubt is half of power means like 76.6 watt here and 76.6 watt here. Now what is my doubt? Now my doubt is whether this power is the power delivered to the load or this is the power that is incident on the load. This 76.6 watt, 76.6 watt. Here what was the power? 153.06. Now half of the power is going here and half of the power is going here. Now this power is equals to the power incident on the load or power delivered to the load, because power incident on the load was PA and power delivered to the load was 1 minus gamma square into PA. So which thing we are calculating? This thing we are getting or this thing we are getting? Try thinking about it. Put pressure on your brain and think whether it is this 76.6 watt, whether it is power delivered to the load or power incident to the load. This is the power delivered to the load. Why is that so? Because what did you replace this transmission line with? What did you replace this transmission line with? Z-in. You did not replace this transmission line with Z0. You replaced this transmission line with Z-in. You also replace this transmission line with Z-in. Z-in means this was equals to ZL2 only and this was equals to ZL1 only. So if you are replacing the transmission line with Z-in, that means you are taking in action every incident, reflection, everything. So if you are saying that I replaced my transmission line with Z-in, then I calculated the power. Then again I replaced it here with Z-in. If then I calculated the power, that means I am calculating the power delivered to the load. Because when we replace our transmission line with Z-in, that means we are calculating the power delivered to the line. So this is the power delivered to the line. This is not the incident power on the transmission line. No, this 76.6 watt is not the incident power on the second transmission line. No, this is the power delivered to the line, right? And power delivered to the line is equals to power delivered to the load. Are you getting this point or not? A very, very important point. And believe me, like this is the, what do we say? This is the heart of this question. That here if Z0 was mentioned, then what a lot of students would have done? That sir 76.6 watt, then what I will do? Z0 is mentioned, I will calculate gamma L and then my answer would be 76.6 into 1 minus gamma L square. This thing I have seen in a lot of notes as well. But this is absolutely incorrect. If you are replacing your transmission line with Z-in, if you are finding the Z-in impedance here, if you are finding the Z-in impedance here, that means you are calculating the power delivered to the line, not power incident on the line. Okay, very, very important thing. This 76.6 watt is the power delivered to the line, not power incident on the line. So this thing we are going to write down. And I hope you must have understood, because we are replacing our transmission line with Z-in, and if we are replacing our transmission line with Z-in, that means we are finding complete power delivered to the line, not only the incident one. Is that clear to you? So this value 76.6 watt, 76.6 watt is not equals to P in 2 plus. This is equals to P in 2 plus into 1 minus gamma L square. Is that clear to you? Right? So this is what I am going to write down now. So this is 153.06 watt we are getting here, and then power delivered to transmission line 2 and transmission line 3 is equals to 156.03 divided by 2. That is coming out to be 153.06 divided by 2, roughly around 76.6 watt I can say. 76.6 watt. Now what is this 76.6 watt? So this 76.6 watt is not equals to the power incident on second transmission line. Is not equals to the power incident on transmission line. Power incident. This is equals to the power delivered to the transmission line. To the transmission line. Why is that so? Because replacing your transmission line with Z-in, not Z0. Replacing transmission line with Zin. If you have replaced your transmission line with Zin, that means you are finding power delivered to the transmission line. And power delivered to the transmission line, we know that it is equals to power delivered to the load. And here, what is the load? Here the load is antenna. Is equals to power delivered to the load, and here the load is antenna. Now every single question related to power you will be able to solve. That's my sure guarantee to you. No one can stop you from solving any single problem related to power. And not much questions has been asked on power, because this is slightly confusing topic. Okay, like there are a different terms, incident, delivered, then how the power delivered to the line is equals to power delivered to the load. Okay, and when do you call it power delivered to the load? When do you call it power incident on the line? A very different terms are there. So I hope we must have understood every single thing in a detail, and all the related concept we have completed. And these are the three patterns, these are the three type of questions that can be asked in your examination. Okay, so I hope you will be comfortable, and I hope you liked the analysis. I hope you enjoyed the video. So now we are going to study about scattering parameters. So that will be our next video. Scattering parameter also becomes important because this has been mentioned in your syllabus as well, and less questions has been asked. But recently in 2023 only they asked the question on scattering parameter. So in 2025 and in 2026 I am not expecting much question from it, but 27 onwards I can expect some question on scattering parameter. But again, do not drop it, because anything can happen in the examination. That would be roughly around 90-minute concept, so you will be able to complete it. In those 90 minutes only you will be able to understand everything related to scattering parameter, and in your masters as well you will study scattering parameters in a great details. Okay, so that we are going to see. Then we will see Smith chart and our chapter will be completed. But one more important discussion I am going to do once we complete the chapter. Okay, so once we complete the chapter, one important discussion I am going to do as well. Well and good. Okay then. So keep on sharing, keep on liking. Okay, thank you very much.